Last week we were talking about the RAM, and this week we will continue talking about the RAM, and we will see how the RAM operates and how to design a RAM. So the whole purpose is to be able to design a RAM with different sizes. Mainly this is what we will be talking about during today's class. So let's start. So the first thing we have is the RAM, and we said RAM is basically called random access memory. The reason for calling it random access memory because you can access any location in the memory just by having the address. So the only thing that you need to have is the address. طبعا the name random came from the fact that other storage devices, they have different ways of accessing memories. And if you recall, in previous weeks we have discussed different types of memory access methods, such as sequential and associated methods that were discussed. So RAM is basically random access memory because we can access any location in the memory randomly as we please. So we said that you have a memory location and you have an address for each memory location. If you supply the address, then you will have a memory location for that address. And we said that if this is the block diagram of a RAM, and if you want to design a RAM, it's quite straightforward. All you need to know is the size of the RAM. We said 2 to the power k multiplied by n, where k is the size of the address bus, while n is the size of the data bus. Okay, so it all depends on k and n in your RAM design. Of course, we have the chip select and WR. Chip select to select the chip. If chip select is 0, then nothing will happen. If chip select is 1, the functionality will depend on W and WR, which is write. If it is 1, then we write to the RAM. If it is 0, then we read from the RAM. And we said last time that usually when we check the size of the RAM, we check it in bytes. So if a RAM is having a size of 2 to the power 24 by 16, 2 to the power 24 by 16 is basically the whole size of the RAM. But if I ask you what is the storage of the RAM, you will have to find the 2 to the power 28, then you will have to divide it by 8 bits, then you will tell me it is 2 to the power 25 bytes. 2 to the power 25 is basically 2 to the power 20 multiplied by 2 to the power 5, which is 32 megabytes. This is how you say the size of the RAM. If you recall, in the assessment 1, I asked you what is the size of the memory, and I gave you different numbers. I don't want the actual value. I don't want you to give me on the calculator 2 to the power 20 is this number 48,576. What I want you is to tell me 2 to the power 20 is mega, 2 to the power 5 is 32, then it will be 32 megabytes. This is how we measure the size of the memory. We never measure the size of the memory in bits. And when it comes to RAM, regardless of how it's built, we want the final size of the RAM, then we can build it using the specifications that we have. Now, how to read from RAM and to write to the RAM. Reading from the RAM, we need chip select to equal to 1, WR is equal to 0. The data will be available on out, and the address that we want to read from will be given on the address bus. In order to write to the RAM, WR should be 1, chip select should be 1, the data will be given to data, and the address will be given to address, and the out will not be used. This was discussed previously in our previous class. Now, let's start by designing our RAM. When you want to design a RAM, the first thing you need to have, which is, let me open the Where is the whiteboard? I just want to open the whiteboard. Okay, so the first thing that you need to have is this device. What is this device? What is this device?
Multiplexer.
لا مش multiplexer. What is this device? Come on. This is a decoder. If you read here, this is a decoder. What does a decoder do? Decoder, just to recall, if you have a 2x4 decoder, remember decoder, the size is 2 multiplied by 2 to the power n, where n is the size of the inputs. Sorry, size of the decoder is n multiplied by 2 to the power n. So if I have 2, it will be 2 to the power 2, which is 4. So a decoder will have 2 inputs. Let's say I input 0 and input 1, and it will have 4 different outputs, which are A0, A1, A2, and A3. Now, this is a 2x4 decoder. If you recall the truth table of a decoder, it was if I have I0, I1, A0, A1, A2, and A3, then we will have this sort of table. Okay. So 0, 0, 1, 1, 0, 1, 0, 1. Hopefully I can draw the table right. Oops. ليش طيب هيك؟ بلاش. Okay. So when we give 0, 0, this one will be 1, 0, 0, 0. When we give 1, 0, this one will be 0, 1, 0, 0. Then we will have 0, 0, 1, 0. And finally we will have 0, 0, 0, 1. So one of the outputs is always active in a decoder. One of the outputs is always active. How will this benefit us? If you go back to the RAM here, you can see that I will give the address over here. So if my address is 0, 0, chip select is the enable for the RAM, and this is the WR. If I give the address as 0, 0, Q0 will be 1. This one will be, these will be zeros. So the chip select for this cell will be active, the rest will not be active. So whatever is on this cell will be either in the output if it's write, or will be on the input if it's read. So the decoder will control the whole process for us. The decoder will control the whole process with us. So we can use these cells to make a 4x1 RAM. Now this is a 4x1 RAM. ايش 4x1? It has 4x1. Remember, it is 2 to the power k by 2 to the power k by n. Now n will equal to 1 and k is equal to 2. The address bus is equal to 2. K is equal to 1. Now what does k equal to 1? 2 to the power n by k, which is 4x1. When k is equal to 1, this means we have only 1 bit stored. يعني if I tell you I have 4x8, this means I have 4 rows and 8 columns. Each row or each memory location can hold 8 bits. But over here we have 4x1, so each memory location can hold only 1 bit. Now, since there are 4 words address, we need 2 bits. Each word is only 1 bit, so data and out are 1 bit each. Word selection is done with a decoder attached to the chip select, and the RAM cells, only one cell can be read at a time. Notice that the outputs are connected together to a single line because we have K equal to 1, so you will have only one output over here. Now, this is a tri-state buffer or 3-state buffer. The usual buffer, this is an inverter. Okay, if you give it 0, it will give you 1. If you give it 1, it will give you 0. And this is what we call a buffer. If you give it 1, it will give you 1. If you give it 0, it will give you 0. Why do we need a buffer? Anyone knows why do we need a buffer? Okay, a buffer is basically used so that you can restore the logical levels of or logical signals. يعني sometimes you just your data is traveling too long and you want to restore the digital level or the logical level for it. So it's quite very important to have the buffer available for you. Now, a tri-state buffer is basically works like a switch. A tri-state buffer works like a switch. If it is closed, then the input is connected to the output. If it is open, the circuit is disconnected. This is what we call high impedance. High impedance or high Z. High impedance or high Z. So a tri-state buffer basically controls the state of basically opens or closes the circuit. We use it as a switch because sometimes if you give logical 0, it's considered an input. Sometimes you give logical 1, it's also an input. So you need some value that will control these things, and basically what we end up with is a tri-state buffer. Tri معناها 3 means 0, 1 high impedance, 0, 1 disconnected. So 3 states for this buffer. So the triangle represents a tri-state buffer. Unlike logical gates, the output can be one of either 3 possibilities, which is high impedance, logical 0, or logical 1. Now disconnected means no output is presented at the time, in which case it's safe to connect the output to another output signal. The disconnected values is sometimes called high impedance. Now this is one method to connect the RAM by using a tri-state buffers. You can see that here the output is connected basically to tri-state buffers. This is very safe. This means that these outputs are always disconnected, and this is the output. هذا part over here is supposed to be connected over here, but for simplicity we did not add it. For simplicity we did not add this part. So basically it's connected over there. This will make sure that this will make sure that our circuit is connected to the right place at all time. So you can connect several 3-state buffer outputs together if you can guarantee that one of them is enabled at any time using the decoder. This is the easiest way to do that, is using the decoder. Decoder مرة تانية, it will guarantee only one output is high at any time. It will guarantee that only one output is high at any time. Now if the decoder is disabled, then all of the tri-state buffers are open and your output is not connected to anything. If the decoder is enabled, then one of the output is connected to your result. So the net result, we can solve we can save some wire and gate cost. We can get a little more flexible by putting the circuits together. Now, this is a 4x1 RAM. Nobody wants to connect a 4x1 RAM. Let's say that we want to connect a 4x4 RAM. 4x4 RAM is a car, by the way. Anyway, we want to connect a 4x4 RAM. ايش يعني 4x4 means instead of holding one bit I want to hold 4 bits together. If instead of holding one bit I want to hold 4 bits together. So how I will do that? We will basically duplicate this circuit. Duplication of the circuit means I will copy this part 4 times beside it like this. See, if we trace any line, let me change the color from red to let's say black. Now you see Q3, it is connected to this cell, and it is connected to this cell, it is connected to this cell, it is connected to this cell. If we talk about Q2 is connected to this cell, Q2 is connected to this cell, Q2 is connected to this cell, and Q2 is connected to this cell. If we talk about let's say Q0, the same idea, Q1 is the same, Q0 is connected to this row over here. So what we end up is a duplication. We end up with a duplication of this 4 times. We end up with a duplication of this 4x1 RAM 4 times. Connections are all connected together. يعني data 3 is connected to all these cells. Data 2 is connected to these. Data 1 is connected to these. Data 0 is connected to these. Same applies for output 0 is coming from this row. Output 1 is coming from this row. Output 2 is coming from this row, from this column, sorry. And output 3 is coming from this column. Chip select for the whole IC is connected to the enable over here. The WR, this WR line is connected to all 16 cells. The WR is connected to all 16 cells. You can trace it here. You can see that WR is connected up here to here, 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 and here. Same applies. This is the line for WR here, here, and here. And over here it's the same story all over again, here, 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 and finally we have it over here as here, 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 and here. You can see that WR is connected to all 16 cells. The address is still 2 bits. Now this is how to create a wider RAM. Now let's say we want to create a bigger RAM. Yani I want to create a 64K by 8 RAM. If I want to create a 64 by 8 RAM, عندك few things to do first. First, what is the size of the address bus? If I tell you it is 2 to the power what will give me 64K. 2 to the power what will give me 64K. To answer this question, first of all, you know that the K is 10, 2 to the power 10. And you need to find what is 2 to the power what will give me 64. You either memorize it or you do it by calculator. You either memorize it or do it by calculator. So if you want to do it by calculator, you have to use the len. You need to find, you will say something like this. You will say 2 to the power x is equal to 64. So you will say len 2 to the power x, len 64. Then you are going to send the the x over here. You are going to say x is equal to len 64 over len 2. If you do it on the calculator, do I have len here? Yeah. I will say len of 64 is equal to, len 64 divided by len, it's not like that then. Len 64 len divided by open bracket to len, close the bracket, it is equal to 6. You see, this is the answer as 6. You got the idea? You use the len. Of course, on your calculator it's easier. On this computer it's a little bit more difficult, but I wanted to show you the idea. So you will do it and you will find x. So here it is 2 to the power 6. So you now know that it is 2 to the power 16 will give you 64k. So now I know that the size of the RAM is 64k by 8. This means that I have 16 address buses and 8 data buses. 16 address buses and 8 data buses. Do you have any questions until now? Anyone has any questions?
Doctor,
نعم.
for the last slide for the three-state or tri-state, same as a transceiver?
لا 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 لا. This is a tri-state buffer. Transceiver is a transmitter and receiver circuit. The buffer is basically a circuit that restores the digital level. هلا signal, usually your signals they travel in wires. As they travel in wires their voltage decay. يعني الفولتج ببلش ينزل. وهي السيجنال ماشيه في السلك الفولتج ببلش ينزل. انت عندك حد معين. إذا متذكرين في أول week we talked about digital levels and we said that there is a minimum level for high. هذا المينيمم level for high ما بيصير البفر أو ما بيصير السيجنال تنزل عنه. رح بنضلنا السيجنال is moving in the wire until it starts to decay. Once it starts to decay into a certain level we put a buffer. البفر ايش بيرجعها؟ البفر يعني السيجنال ماشي هاي 5 volts. السيجنال ماشي ببلش تنزل 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 تنزل. And if we add a buffer here البفر بيرجعها مرة ثانية ل 5 فولتس. بيعمل ريستوريشن للديجيتال ليفل. البفر بيرجع ال 5 ل 5 والزيرو ل 0. اوكي؟ البفر برجع 5 ل 5 و0 0. البفر موجود في النتوركس. طيب اذا النت عندك ضعيف في البيت ايش بتعمل؟ مش بتجيب الاكستندر نتورك اكستندر. You know the network extenders. If you have the Wi-Fi very slow at if the Wi-Fi does not reach all the rooms ايش بتعمل؟
هو الاكستندر دكتور.
هو الاكستندر ايش هو بفر؟ ما هو الاكستندر بفر. الاكستندر مقوي للسيجنال. الاكستندر باخذ السيجنال الضعيفه اخر سيجنال وصلت لعندك وبرجع بيعملها ريجنريشن. هو بيسكلي بفر. اوكي؟ الاكستندر از بيسكلي ا بفر. وضحت الفكره؟
Yes, Victor, clear. Thank you.
Okay. Now, if we go back to the RAM over here, you can see that we want to design our RAM. Suppose that we have a 64 by K RAMs to start with. We want to build a 256K by 8. So, what I have to start with, we have 64, oh, sorry. So we have a 64K by 8 and I want to use it to build a 256K by 8 RAM. So the first thing to think about is how many blocks of this I need to use to build this one. So to get the answer, it's quite simple. You will take 256K divided by 64K. So K by K will go. 64 by 256 will give you 4. So I need 4 blocks. For the data, this is for the blocks. For the data, it is 8 divided by 8. So it will be 1. So my design will look something like this. I will have 1, can copy this one. One, two, three, and 4. Now, these 4, I need to know a few things about them. So I will write over here. 256 K. What is the size of the address bus for it? So what is the size of the address bus? So we will say K is 2 to the power 10. 256. 256 is 2 to the power what? Two to the power 8. صح? So the size of the address bus over here is 18. And the size of the address, so the size of the address bus, it is 2 to the power 18 by 8. And the building block is 2 to the power 16 by 8. ليش 16 اللي هي 256 64 وال 18 اللي هي 256. So I want to build this one from this one. So the size of the address bus over here will give me 18. The size of the address bus over here will give me 16. And if I do 18 minus 16, it will give me 2. So 2 is my building block for my decoder. So this is another thing. So my block of decoder will be 2 to the power 2 by, 2 multiplied by, which is n multiplied by 2 to the power n. So it will be something like this. It will be 2 multiplied by 2 to the power 2, which is 2 multiplied by 4. 2 by 4 is my decoder. Now I know the size of the decoder. The numbers should add up. يعني أنا لما بحكي هنا the difference address bus is 2. 2 to the power 2 should give you 4. واللي هو نفس الرقم that we got over here. You should get the same numbers. Okay? You should get the same numbers. I just want to make this one more clearer. 2 by 4. Now, 2 by 4, this one is, this building block is 64. Let me zoom in so I write easier. This is 64 by 8, 64 by 8, and 64 by 8 and 64 by 8. Now, what is the size of the address bus over here? We said it is 16. So the address bus for all of these, I will do it in red. This is my address. It is address from 0 to 15. And the size of it is 16. The size of it is 16 lines. It will take from 0 to 15. It will go over here inside to address for all the 4 chips. Now, this is, let me fix this one again. Okay, this is for the address bus. Now, the size of the full decoder, okay, the size of the full decoder is 256, which is 2 to the power 18. 2 to the power 18 minus 16 will give you 2 lines, which leaves us with the decoder having, our decoder having 2 address lines for it, which is address 16 and address 17. Now you have 18 address lines, and the outputs are This is A0. This is A1. This is A2. And this is the final one is A3. They are all connected to which pin? To chip select. They are all connected to chip select inside the RAM. Of course, all our RAMs are connected to the same WR line. So I will do the WR. This is WR. WR, and here is the chip select. Okay, WR, I don't want to confuse you. So WR over here in green, and WR will be connected to all the ICs over here. This is WR, and this is WR, and this is WR, and this is WR. Now, another few things to add is the over here we are going to add the chip select for enable for the RAM, for the decoder, and two things are left. These two things are the two main things, which is data and out. So data, okay, let's do data. Data will be, it's not clear, RAM. Okay, so data will be this. Size of data is 8, and finally we have the out line, which is, let's give it a color of yellow. This is our out at the end of the day. Okay, at the end of the day, this is your RAM. At the end of the day, your RAM is basically the following. Your RAM is basically, it is a 256K by 8 RAM. It will have an address of from 0 to 17 lines, which is 18 lines. This is our address. You will have data as input. You will have data as input, which is 8. You will have WR, and you will have chip select, and your output will be 8. If you look at the above design over here, it has the same ideas, but this is how you do the design from the inside of the RAM. So the first thing to do is to figure out what is the size of the total size of the RAM, how many blocks do I need, and how to connect these blocks together. This is basically the idea of designing RAM. So over here you can see that a design example is a 256 by 8 memory, given that you have a 64 by 8 chip. For the 64 words, we need 18 address lines. The two most significant lines, which are these two lines, it's the same that I did, 16 and 17, will be connected to the decoder. The from 0 to 15 address will be connected to the addresses of each block of these. You have 8 data lines, you have 8 output lines, you have a WR, and you have the chip select over here connected, as you can see. Okay, so I will stop here now, and I will continue at 11 o'clock and try to finish the whole idea of the RAM.